Okay, so in this part, let's talk about collisions and collision events. Uh, so I will create a new particle system. So let's say I will create write a geometry. Okay, with this I will add PopNet, the old one, and let's say I will add a point in space from which I will emit my particles. Okay, so adding source, use first context, and let's add a bit of uh, velocity by adding normal. Add normal. Wait, so for example, like so. So now my point has normal, and particles go up. Yeah, alright, I will change my normal to x. So now they're moving in this direction. Alright. So let's say I want to collide my particles with some object. I will create a new object, let's say a sphere, something like this. And let's turn off the grid and make a sphere smaller so it looks better. Alright, so now particles is emitted and they go into the sphere and coming through. Let's say I want to make my particles hit the sphere and die. So what I can do for this? Let's change the primitive type of sphere to polygon. And maybe a bit more polygons. And let's connect it to second input of PopNet. Alright, so now let's dive inside. And here I have just the source. So let's create a collision node. It's called collision, and connect this. Alright, so let's see what do we have here. The first step is collision, and it asks for geometry source. So as usual, I can choose which context to use. So first is first input, second, third, and fourth. Alright, so I will choose the first context. Uh, this one is show how to percept the object for simulation. So it basically controls the algorithms for moving. Okay, but we have static geometry, and here is behavior. On behavior tab we have diagonal collision, bounds, and all the types of different interaction with collision surface. So let's say I want to kill them on collision, and here I need to set the collision event. So let's say I will call it hit event. Okay, and here I can put all the particles which will hit the surface into a group. So something like this, and let's preserve it so the group will grow up from frame by frame. Okay. Oops. Constraints and attributes. Here we have attributes which will allow us to create some attributes for particles. But for now, let's play the simulation. And yeah, nothing happens because I accidentally set my geometry source into wrong context. So it must be a second one, so I got my sphere here. Alright, so let's play the animation. And you see once the particles reach the surface, they dying. I will move the sphere a bit closer, like this. So, alright, let's see one more time. I emit particles, and for now I have 242, 246, 50, yeah, and now number is not growing. Alright, and for example, if I change the collision behavior from die on collision to, for example, slide on collision, the particle behavior will be different. So they're start to sliding and then changing the direction. Alright, so here is bounce. So they start bouncing, stop, and continue on course. So the collision event happens, but nothing happens to particles and stick. So they're just sticking here while the number is keep growing. Yeah. Alright, so let's set die on collision. And how we can use it? Well, for example, when collision happens, the collision event like starting. So I can control anything I want by this event. Just to show you an example, I will emit particles from the sphere when these particles are hitting it. So I will create a source, and let's call it emit from sphere. Emit from sphere, and let's do merge. Well, here it called not merge, but collect. Yeah, so this taking view particle system into one. All right, and let's set second context geometry because this one is connected to a second one, and birth rate. Let's leave it for a moment. So now I have particles emitted from my sphere. Alright, so let's put some normals into the sphere. Alright, add normal. Like this. And let's set it to -1, so the particles will move in this direction. Okay. Now let's dive inside and let's set constant activation. Instead of 1, it must be an expression. So let's type pop event, and here I need to type a name of my event from collision. So hit event. like this. So for now, the heat event is not happened, so the value is 0. Playing my animation, and once it hit the surface, heat event turns into 1. So particles start emitting from sphere. Okay, and here again I can add some noise into here, so the particles will move a bit more interesting. Yeah. Or I can put my expression from constant into impulse. So this might emit simulate the explosion. So let's say 5,000 particles will be emitted when it's hit the surface. Yep. All right. Looks pretty nice. All right. So that's heat event. Oh, and let's check the heat group. So for now, heat group should be 0 or empty. Okay. So yeah, it's 0 in heat group for now, and hit the surface. And now I have 4 points in heat group, and it's not growing because, well, it should grow, but particles are dying. If I set stop on collision, the group will be bigger. All right. And again, I can apply some, for example, force to heat group, and let's say move them in this direction. And where are they? Well, to split, I can set delete or remove. Now in particle system it calls kill. So yeah, I have kill node here, and I need to select the source group and the event and group. So let's say these particles will be sphere group. So I preserve group, so this will grow. And let's kill this. So now they should die. Yeah, so they emitting and dying immediately. Yeah. So where is my these particles? Heat group force, noise. Stop on collision. Okay. Yeah. So I need to set continue on course, because otherwise the particles will stop or die and the velocity will be 0. But now the particles keep going, and inside of sphere they receiving a new velocity by force node and moving in new direction. Yeah, like this. Really nice. All right. Now let's say I want to attract my particles to some point in a space. So I will take my first source. So let's move it here. and disconnect and deactivate. All right, so I have particles, which is moving like this. And let's say I have a point in space which I want to attract my particles. So I will set location and let's say 5. So my location is here. So let's do it like this. Or maybe 2.5, so it's closer. Yeah, for example. All right, so what I need to do, well, okay, my location is emitting particles. So let's kill it. Okay, so there is a node called follow. And here is 2 inputs. First one is follow object and leader. So the leader is like a traction point. And I connect it like this. So my source is object which should follow to somewhere. And the point of interest is my location. So, okay, now let's play the animation, and that's moving like this. Why so? And the reason is that even if I have a location which has the coordinates, there is no point in space which will attract the particles. So let's say it's here. All right, and now I need to create this particle or point. I can do it on this level. So instead of sphere, or I can use sphere, but now we're trying to make it with point. So yeah, let's emit just one particle from this location, and this particle will be like a goal. So to do this, I need to set impulse activation to expression $f equal 1. So this will be true only on first frame, and birth rate set into 1. Okay, and let's turn off constant activation. Okay, and I have this particle, but it's flying away. The reason is that I have variance in velocity here, so I need to set it to 0. So the point will stay on the same place for forever. And now play the animation. All right. That's strange, because it should work like this. So if there is no velocity on this point, maybe I should add a bit ambient speed to the particles. Yeah. So if I set it to 0, particles will stay in the place, and ambient speed will add the action. Like this. And again, let's add a bit of noise by adding the force. and apply some noise. Turbulence. Yeah. And rate of offset, scale. Right. And more amplitude. So now even if I have really huge amplitude, so the initial particles are like flying away, they still tend to go into this point. Okay, like this. Right, and adding of little offset by $ID plus some value, like so. And yeah, so now it's like a flow and particles are going to this position. All right, but if I want to send my particles to, let's say, to sphere, I can switch my goal, turn it off, and delete constant activation, delete channel here. So constant activation 0 and impulse is $FF equal 1. And well, let's say 10. So I have 10 points here, and they're flying away because of inherited velocity. Yeah, like this. But with the polygon object, it's possible to send particles to each vertex. So instead of having some particles here, I can do like so. And yeah, particles are stuck because, all right, I need to bring back the normals. And I need to do this. Let's add add node. And the add node allows us to delete the polygons but keep the points. All right. And for each point, let's add the velocity. Like this. So now it should work. No, it's not working. Well, okay. Instead of tracking to the sphere, we can create the right amount of particles. This is 162. So let's do it this way. There's a lot of different ways you can achieve the same stuff in Houdini. So 162 and all right, turn off the normal. Probably probably I did a mistake because it looks like the sticking to each point is available in new particles, a new particle system, not in the old one. But it's definitely possible to do it here, while it will be maybe a bit more complicated. Point surface ordered. Yeah, so there is different emission types, and okay, so they don't want to stick to each point here. Well, at least they stick into to the center. Okay, there is one more thing in follow node. Here we have two different types of behavior, and currently we've been using a normal flow, and the simulation looks like this. So I just decreased the amplitude of the noise. Yeah, you can see, and scale. So like this. Um, so if I change the behavior to accelerating follow, currently the particles will flow like this. It looks like mass even if they following the sphere. To make it more usable, I will change my force, and now you see particles hitting the surface, flying away and going back. And I will set the noise to smaller value. You can see it. Yeah. So it also allows us to get a really nice effect. So now particles going back in the same way. So a bit of noise is really necessary to get something useful. All right, and here is attract distance. It basically tells on which distance the attract force will work. So now it goes in the reverse side. Yeah. So if I set the frame range to a bit longer, turn off this, so you see it create this nice effect. So the particles are going from here into here, and then the forces start to dragging them back, and that's what happens. Okay, and yeah, so that's all about attracting particles.